Hey everyone, in today's video, we're going to see about XGBoost, a well-known and widely used algorithm which is better than neural network, random forest, and other basic algorithms. I'm going to explain how it works, not too technical, but only the needful. Companies like Uber, Airbnb, and Netflix, they majorly use this algorithm in order to identify the key factors from the data. So it is built based on decision trees, and errors have been rectified using gradient boosting. So it is majorly termed as extreme gradient boosting. The boosting happens by building trees sequentially. Gradients, which is basically about derivatives to find best improvements, and regularization it uses in order to prevent the overfitting, and tree pruning just to identify the purity of tree by having the max depth limits. So let's see XGBoost step by step, how it is actually working technically. So you will have a base prediction. Initially, you start with a base prediction, a value for every row. That is what they do. So for each row, you will have a value of base prediction to start with. Later, based on the error in the sense you compare with actual and predicted values, right? The subtracted value of actual and prediction, that is your error, which terms as residuals, they say. And with that, it aligns back. So we have this back propagating thing, right? So similar to that, we're just going to make changes in the tree. So the next tree with a modified value, it trains again and you will have a better prediction compared to the previous value. The previous base prediction. So that is how this entire XGBoost works, and that is how this repetition changes the value and accuracy will have a better predicted models. So when we say training and a tree for every iteration, we say like this. So we start with a base prediction, right? So error, we just say compared with the actual and predicted value. So for every change in the tree, it back propagates. Back propagation is not a right word. It is going back and realigns with the value along with the learning rate, with the help of learning rate. So it changes the prediction by fine-tuning the values according to the actual value. So we get less errors in every iteration. So let's say like having auto training of taking 10 trees, we can see the change in the value compared with the previous, initial errors. So we'll have like better model and accuracy compared with the initial predicted values. So that's how it has. So initially we had like, let's say like house 3 had predicted values 265, but actual is here 320. Now let's start with the training. So we have like very close towards the actual. We do have error, but it is minimized drastically in this 10 trees of every iteration. So each tree is each iteration, let's take in that way. So for each iteration, it have been improved, and the prediction have been improved. The error have reduced. So that is how this entire training works. So the split happens the same way in decision tree. So it is basically a decision tree inside, and the tree have changed depends on the errors happening to it. So this is a log that you can see for small house, large house. So we have this split. So below 1500 square feet, which considered as small, and above is your large square feet. 1500 square feet is large. So with that split, we are getting error reduced approximately. We are seeing like the prediction is 265 of. So the base prediction technically means mean of all prices. It is a mean value that they initially started with, and drastically it is showing improvements in every iteration. So that is how they see the accuracy value, but we don't have to go that much in depth. We have a algorithm for it. So here if you see, we can just install XGBoost and have a train and test split, and finally we can have a model, the prediction value. So we need to define these estimators, learning rates, and maximum depth. Random state. Random state is to avoid the randomness from your accuracy, the predictions. For that, we are using random state, and you'll have the model. You don't have to specify each and everything, the parameters for the algorithm. It is there. So understand how it is actually working behind, so that we can change some of the values, like learning rate. We can go with higher, like 0.6, in order to have a better predictions. So with that, we can just have the mean square error reduced from the initial level. We can just have the comparisons for it. So that is how it is actually. So you can see the pros and cons. It is better than random forest, linear regression, neural networks, as I said, due to it handles the missing data very well, because it has a regularization method inside, and sort of to avoid the overfitting. But for neural network, we need more data. Then only we can have this model or algorithm to work fine. But here we don't have to concentrate on higher data, large data. We can have like limited set of data for a machine learning algorithm. So that helps with it. So anything that you do with the complex data, you can start with XGBoost instead of going for linear regressions. So this works fine for demo purposes. You can't just rely on linear regression for production level applications. You can go with XGBoost or random forest for medium range, approximately having like manageable data. You can go with these two models instead of like directly going for deep learning models. So yeah, that's all I have for XGBoost. If you have any questions or doubts, you can ask me in comments. I'll reply to those. Yeah, so that's all. Thanks for watching. See you next video.